at one corner is pressed. Okay, that is the area. This is the area. Can you see this? This is the area which is pressed, not the complete hand, not the full hand. So I can feel the pressure only over here and nowhere else because I am concerned with the area which I am pressing. You understand now? So the pressure depends upon the area where the force is applied. Okay?
Pressure
Please read.
is the pressure is the force acting per unit area. Pressure for force
Is equal to,
area
you have
is
to say
equal
like
to
that.
force area. P is
Force,
equal to
just a moment. Pressure is equal to force
pressure is equal to
divided by,
force
divided by,
divided by area. Is pressure divided
P
by
is equal to,
force.
P is equal to F upon A.
P is equal to F upon A. Unit of pressure is
Pascal.
Pascal, Pascal,
Pascal.
Pascal PA. If the area is smaller, the pressure is more on the surface for the same force.
Fine. Thank you. Now, as it is, we have studied that pressure is the force acting per unit area. Just now we learned that. So, what will be the formula? Pressure is equal to force upon area. Pressure is symbolized by P, force is by F, and area is A. So, P becomes F upon A. And what's the unit of pressure? Unit of pressure is Pascal, that is PA. Now, if, for example, area is small, because you see over here, by this formula, P is directly proportional to F, whereas P is indirectly proportional to A. What do you say? You agree with me? Hello? Boss, do you agree with me?
Yes, ma'am.
Okay. So if A is more, then P will be less. If A is less, then P will be more because it is indirectly proportional to each other. Have you understood now? Yes. Do you understand what I said just now? Because it is indirectly proportional. If one is more, the other has to be less. Right? Hello? Can you hear me?
Yes, ma'am. Yes, ma'am.
Okay. This I will teach you. It's going to see the relationship between force and pressure. So you can see here a pump. What you are doing? Can you keep on pushing? No. You have to pull and then push. That's how you fill the tube, isn't it? The tire. You fill the air in the tire tube, isn't it? How do you fill the air in the tire tube? By only pushing or by pulling and pushing? How do you fill the tire tube? Yes, boys. Hello.
Yes, ma'am.
Yeah. How do you fill the tire tube? That you got a pump, isn't it? To fill the
Yes,
tire
ma'am.
tube, air. So how? What is the mechanism? First you have to pull, and then you have to push the handle, isn't it?
Yes,
Then
ma'am.
only you can apply the pressure, and the air comes out with a force, and your tire tube gets filled up, isn't it?
Yes, ma'am.
See how? See the mechanism. He's applying the force. It is going down. The air is being pushed into this tube, and then it goes to the tire tube and gets filled up. So what we are doing? A force is applied to the pump. So this person is applying the force. So you can see the direction. You can see the direction. He's pushing the pump down, isn't it? And that pressure is called as pressure. What is it called, Vita? Air pressure, by which it travels into the tube, and then from there it goes to the tire, and the tire gets inflated. You understood? Hello? Did you
Yes,
understand
ma'am.
the
Yes.
mechanism? Oh, okay. Now, how do we increase the pressure? By reducing the area. Let's see.
A sharp knife has a very small surface area on its cutting edge so that high pressure can be exerted to cut the onion.
Okay. Now, you must have observed the knife. Yes? Now, my question is that the edge, this one, and this one, is it same? Is it same? Hello? Boys, can you hear me?
Yes, ma'am.
Yes, ma'am.
Yes. What did I ask you just now? I asked you the area of the upper edge, is it the same as the area of the lower edge? Hello? Can you hear me better? Can you hear me?
Yes, ma'am.
Yes. Give me the answer then.
What?
I said, is the area on the top is same as the area at the bottom?
No, ma'am.
No. Fine. That means on top, the knife is thick, whereas at the bottom, the knife is like this. See. Yes or no? It is V-shaped, isn't it? This edge,
Yes, ma'am.
this edge is V-shaped, like it is like this, isn't it? Sharp. So that with small effort, it can cut the onion. It can go inside the onion. But if I take this portion, if I take this portion and try to cut the onion, do you think will it be possible? Hello, will it be possible to cut the
Yes.
onion with
No,
this
ma'am.
portion? Why? Because the area is more. What will you answer? The area is more. Whereas the area at the bottom, this one, is less. So it can go with the force and can cut the onion. You understand now? Hello?
Yes, ma'am.
Yes, ma'am.
Okay, but all of you understood?
Yes, ma'am.
Yes. Please read. Please read. Hello, please read better.
Yes, ma'am.
Ma'am, I can read.
अरे હું read
Yes.
કરું છું. The
Yes.
high pressure on surface of ice so that the ice melts and allowing the ice skater to glide smoothly.
Okay, fine. Who wanted to read better?
Ma'am Zainali Rajani.
Okay. Next slide you will read. Now you can see over here,
Okay, ma'am.
this person is wearing a skate. Can you see this? Can you see the skate? This is the skate. Can you see the skate? Hello?
Yes, ma'am, I can see.
This is the skate. Now the person is skating on the ice. What happens? He's applying the pressure, his body pressure on the feet. From the feet, it goes to the skate. The pressure of the body is on the feet. From feet, it's going to the skate. You understand now? So, where the pressure is applied? On the skate. From the skate, the pressure is applied on the ice on which he is skating. Yes or no? So, now where is the pressure applied? On the ice. Yes? Hello? Where the pressure is applied? On the ice by the skate, right?
Yes, ma'am.
So what happened? When you're applying the pressure on the ice by the skate is moving. Remember that. The skate is moving. There's a friction. You agree with me? There's a friction
Yes,
because
ma'am.
ice and skates are rubbing each other, right? So there's a friction. And I have taught you by the friction what is created? Heat. What is created? Say, heat is created. When the heat is created, the ice melts. You understand? And when the ice melts, the ice skater can glide smoothly. You understand? Because now it is making a space for it. Hello. Boys, did you understand?
Yes, ma'am.
Am I audible? Can you hear me properly?
Yes, ma'am.
Yes, ma'am.
So all of you understand how the skater glides on the ice smoothly? Because the ice melts. When the ice melts, the skate can move easily on the ice. Read please.
Okay, ma'am. Increasing the pressure by reducing the area. When a force is applied to the head of a nail, the pressure will drive its sharp end into a piece of wood easily.
Oh, good. Now you can see this is called the head of the nail. Yes, this is called the head of the nail, right? And this
Yes,
is the
ma'am.
tail end.
Yes, ma'am.
Fine. What was written over here? We are applying a hammer on this head. We are applying a hammer. So you hammer it. When you hammer it, there is a pressure. The force, there's a pressure applied onto the tail end. The surface area of head is more than the tail. Yes or no?
Yes, ma'am.
Yes. So what happens? The tail end is got sharp end. It is V-shaped. See, this is the nail. I'll show you how it looks. It is like this. Yes or no? So the tail
Yes,
end is
ma'am.
always V-shaped. Yes or no? So the surface area is very less as compared to the head. What do you say? So surface area is
Yes,
very
ma'am.
less. So when you apply a force, a pressure is created
Yes,
on
ma'am.
the tail end. Yes, on the okay. So it takes not much of an effort to drive it in the wood. So easily it goes inside the wood. But if I do like this, if I hammer over here, I take a hammer over here and apply the force on the tail end and allow the head onto the wood. Do you think it will be possible for me to drive it inside the wood?
No, ma'am.
No. Why? Because the surface area of the head is more than the tail. You understood now? Understood better?
Yes, ma'am.
Okay.
Yes, ma'am. Yes, ma'am.
Now, again, the same thing we'll do, increasing the pressure by reducing the area, right? Now, let's see how we do it. These are the
Yes, ma'am.
studs. These are called as studs. The athletes, they wear these shoes for running. Read better.
Okay, ma'am. The pressure under the studs in high enough for
Enough.
them,
It is enough,
enough
beta.
for them to sink into the ground, which gives extra grip.
Okay. Now, a person is running with a high speed, right? So what he's doing, he's applying a force and the pressure is created. Where the pressure is created, beta? Here. Pressure is created here. You got my point?
Yes, ma'am.
Now that pressure is enough that this sinks into the ground. When it goes inside the ground, it gets a grip and it gets a force. It can leap. The person who is wearing this can have a jump, can have a high force, can have a good distance to cover because he will get that extra leap. You understand? Hello? So he can run faster than others. The ones who are not wearing the
Yes,
studs,
ma'am.
the the one who are not wearing the boots with the studs will not have this much of grip as the person with studs have. So he has got more advantage than the ones who are not wearing the boots with studs. You understood? Understood? Because that
Yes, ma'am.
person may not have that much of speed. He or she can slip also because the boots are flat, and the ones whose boots have got studs will have extra advantage of moving very fast. Okay? Okay, beta?
Yes, ma'am.
See, I'm giving you all examples of increasing the pressure by reducing the area. How are we doing that? I'm giving you all the examples. Yes, beta.
Really need very high
Rally,
air
beta.
pressure
Hello.
inside the tires.
Hello. It is rally.
Really need very high air pressure inside the tires because the narrow tires have a very small contact area with the ice road.
Icy road. Okay. Now you know the rally cars, the cars which are moving with a very high speed and they are for a competition, right? So that's called as rally car. There's so many cars taking part in a competition. So the cars which are taking part in a competition are called as rally cars. Now they require very high pressure inside the tires. Okay, why? And always remember their tires are not like the ordinary tires. Their tires are narrower than the ordinary tires. Have you ever observed? Those cars have got narrow tires. For example, if our tires are this big, okay, so their tires will be this much. Got it? The rally tires will be so narrow. Our tires, which we are having at home, will have broad tires. Now, did this much you have understood? This much have you understood? Hello.
Yes, ma'am.
Okay. So why they want to do that? Because they want to increase their speed. So they want small area to have contact with the road. It could be icy road, it could be muddy road, it could be concrete road, anything. So they what they want is the contact area of the tire with the road should be minimum so that they can increase their speed. You understand? Hello?
Yes, ma'am.
Yes? Okay. Look over here. See? If see so narrow, can you see the tires are so narrow? So they can jump, they can leap, they can
Yes,
be
ma'am.
on one side. Now, if the tires are heavy, the car may overturn. The car can meet with an accident. The car can slip. The car can get burst. The tires can get burst also. And the car will be heavy because of the tires, isn't it? So it cannot move fast. So as to have a very good speed, they have decreased the weight of the tires. Understood?
Yes, ma'am.
By making it narrow. So they can jump, they can leap, they can be on one side. You know, you must have seen rally drivers driving their car on two tires on one side. Yes, in movies also you must have observed when people do stunts. Okay, okay. Let's take another example. Read better.
Reducing the pressure by increasing the area. Skies have a large
Please,
area to
please read
reduce.
it again. Please read. When I stop you, you have to stop better. Skis. What is written?
Skies have a large area to reduce the pressure on the snow so that they do not sink in too far.
Okay. Earlier we had done skates. Remember ice skating. You remember now? Now we
Yes,
are
ma'am.
doing ice skiing. Now this is ski. Can you see? Can you observe this? This is
Yes,
the
ma'am.
ski. Okay. Now what about the surface area? The surface area is so big, isn't it? Why
Yes,
they have
ma'am.
taken surface area so big? So that remember the skate sinks in the ice, it melts, and the skater can move on the ice. In this case, in this case, when they are moving at a very high speed, because of the surface area, the ski does not sink in the snow. Otherwise, the ski will, with the body weight, with our body weight, the ski can easily sink in the snow. But it does not happen. Why? Why? Because of the surface area. The surface area is more. You understand? So when I'm applying the pressure on my feet or of my body on my feet and on the ski, it does not sink in the snow because of the surface area. The surface area is more over here. You got my point?
Yes, ma'am.
Oh. So what we have done, we have reduced the pressure by increasing the surface area, and hence the ski it it moves easily on the snow rather than sinking in the snow. Okay, this is another example that we are going to work on. Yes, say, read better.
Reducing the pressure by increasing the area. A tractor moving on soft ground has wide tires to reduce the pressure on the ground so that they will not sink into the ground.
Now we will do something opposite. What is it? Now this is a tractor, right? See, it is a muddy ground. Can you see how dirty it is? It's a muddy ground. Now this tractor has got wide tires, big tires, isn't it? So what we have done, we have increased the surface area. Agree? Do you agree? We have increased the surface area. Can you see this? We have increased the surface area. This much of width is the tire. So big tire it is. So what are we doing? When we increase the surface area, obviously the pressure is reduced. I've taught you already that pressure is inversely proportional to the area. So now more the area, pressure will be less. And when pressure will be less, the tractor will not sink inside the soil, but it can move easily. You understand? Hello?
Yes, ma'am.
Do you understand?
Yes, ma'am.
Okay. Yes, read.
A wider shoulder pad of heavy bag will reduce the pressure exer-
Exerted, exerted,
exerted on the shoulder of the person
carrying, beta.
carrying the bag.
Good. Well tried. You're trying at least. I'm happy about it. Now, let's see over here. Now, the shoulder. This is the shoulder pad, right? He's got a big wide shoulder pad. So the surface area is more. So he will not have more of pressure. Now, what I do? I make it narrow. This much. What will happen? Which one will be more painful? This one or the earlier one?
This one.
This one. Why? Why?
Because the shoulder pad is short, though. That's why we get weight
More pressure,
more pressure.
pressure on that small area because this area has
Yes,
become small. And when area
yes,
has become small, the pressure will be more. And when the pressure will be more, it will hurt me more, right? It will hurt my shoulder too much and it will be painful. You understand now? So
yes,
if I increase the surface area, the pressure will be less. So it may hurt, but not that much. You understand?
yes,
And that's exactly why we say use your shoulder bags, use your carry bags, the bags that the school bags that you carry to the school should have wide shoulder straps rather than because it is painful. Remember, even you get the pain when you carry your school bags, isn't it? So if the bags are not okay, then obviously you get lots of pain on your shoulder. Okay? So when you buy your bag, see to it that your shoulder padding are wide enough for you to carry. Yes, please read.
I'm candid.
Sure.
For a solid block resting on the floor, the pressure ex- acting
Acting
on acting on the floor is high when the
highest,
block is
resting.
resting on its smaller surface.
Okay. Now you see two blocks. You see these two blocks?
Yes,
One
ma'am.
is flat, one is flat, and one is upright.
Yes, ma'am.
You can see this too? Okay. Now, please adjust your mic better. Someone's mic is on, please. Now look over here. The area which is in contact with the floor is this much. Whereas area which is contact with the floor is this much. Can you see this? Can you see this?
Yes, ma'am.
This is the area of contact. Whereas this is the area of contact. So as we know, area is inversely proportional to pressure. We know that, right? So on the left hand side, and this is the right hand side. On the left hand side, the area is small, so pressure will be high, right? The left hand one. On the right side, Area is big, pressure will be small. Hope you have understood. And this is what we have worked with tractor. Remember tractor. And this we have rally cars. You agree? You understand now? The tires of
Yes,
rally
ma'am.
cars had the smallest
Okay,
area,
ma'am. Yes,
and
ma'am.
the tractor's tires were having the big area. Remember? And that's why it does not sink in the soil. In I'm talking about tractors. And when I'm talking about rally cars, that it can leap, it can jump, it can be on sideways, it can run very fast. Why? Because the tires are very very narrow. Any problem? Have you understood the whole
Yes,
concept?
ma'am.
You have to give me answer. What is question? I'm asking a question. Which diagram shows the child exerting the least pressure on the ground? There are four children. You have to tell me which one is exerting the least pressure.
Number B.
Number B.
Ma'am, see.
No, you have to give me answer. Why B? Why C? Okay, you said B. Who said B, beta?
Number B.
Please adjust your mic,
Ma'am
beta.
B.
B. Okay, why B?
B years bola, ma'am.
Ma'am,
Okay,
because
who's B?
because
Who is
the
B?
white
Just a moment.
because
Don't speak
white
in
it
Hindi. Yes. Why B? Because
because the we see in the two box that we have
yes,
large area, the pressure is low. If we have narrow, short area, if the
area
pressure is
more.
big more.
Yes, that's very, very well explained. You're absolutely right. The surface area when you're lying down is the maximum, isn't it? So obviously pressure has to be low. So you're absolutely correct, beta. You're absolutely correct. The answer is B. Okay? All of you understood? Hello?
Lecture over. Yes, ma'am.
Yes, ma'am.
Next is over? Okay. We will do another problem later. Okay, beta? I hope you have understood regarding the area, pressure, everything, how it is related. Nicely have you understood? Any problem?
No, ma'am.
Okay. Have a good day
No,
then.
ma'am.
Bye. Bye.
Bye,
Bye,
ma'am.
beta.
Bye.
Bye, beta.